This is the STS-133 interview with pilot Eric Bowe. Eric, tell us about the place where you grew up and tell us how that place influenced who you've become.
Well, I grew up in Atlanta, Georgia, and it had a big influence on me. You know, kind of put in motion kind of my goals and objectives, and obviously the schooling was a real important part of having the opportunity to work here at NASA. And so for me, the things that I remember as a kid, I remember my just getting started with being very involved with sports in school, and also a lot of other activities with, and I still talk to friends back home in Atlanta.
And what was your favorite sport coming up?
I had a couple. I enjoyed soccer. I participated in cross country, and I also was on the wrestling team.
Okay. Did you have occasion to see the Atlanta area from space on your last flight?
I did get the chance to see the Atlanta area in space. And one of the things that was pretty cool is they were having a Georgia Tech. I went there for my master's degree, and they were having a game. And someone told us as we were flying over, we had a couple crew members on the last flight that on STS-126, and the shuttle actually flew over top of Atlanta, and we were looking down while they were looking up, and they actually talked about it at the football game. So it's a neat event.
Cool. Could you actually see much detail?
No, you could see Atlanta and see the lights. I would like to say I saw the football game, but
yeah.
That'd be stretching a little bit far.
Every accomplishment begins with some form of motivation. You've been an astronaut for about 10 years. Tell us what motivated you to pursue this line of work out of all the things out there that were possible.
Well, what motivated me to be an astronaut, probably the first thing I can remember as a kid is I remember my parents calling me in 1969 to watch black and white TV of the first moon landing, and I was 5 at the time, and as a kid I don't remember a whole lot, but I do remember as I got older, I remember them, you know, the emphasis they put on it, and you know, as I got older I thought about, you know, what a neat endeavor that humans had participated, actually walk on something that you look at oftentimes in the night sky, and so that was kind of set the bid of something, you know, maybe if I was lucky enough and had the opportunity, I'd like to be an astronaut. And I was also very interested in aviation as a kid, and so I was involved in a group called Civil Air Patrol, which is very active with the Air Force and flying and doing a lot of other activities. So that kind of spurred on my inspiration to do flying. I went to the Air Force Academy after that, and I was interested in being a fighter pilot was one of my goals, and got to do that for a while. So those kind of inspirations along the way, and the doors kept opening, and the opportunity presented itself where I was a test pilot at the time, and I was still interested in being an astronaut, so I applied and was lucky enough to be selected.
Okay. Take us back, and if you would, again, recount for us the steps you took in your military career to get to the NASA Astronaut Corps.
Well, as a space shuttle pilot, there's kind of a track to be a pilot and a commander. Typically, the background is you have to be a military test pilot. So I started my career, I was a fighter pilot flying F-4s at Clark Air Base in the Philippines, and then I went on, I was an instructor pilot for a while on T-38s and AT-38s at Columbus Air Force Base. And then I went to Eglin Air Force Base flying F-15Cs, and from there I went to test pilot school, and that's one of those things that I was talking about as kind of a requirement to be, it's not specifically written, but just about every pilot of the space shuttle, pilot or commander, has been a test pilot through a military test pilot school. And then after that I was a test pilot at Eglin Air Force Base flying F-15s.
Okay. When did you first apply to become an astronaut, and how long of a time period was it from when you made that first application to when you finally got the call?
Well, my first application to be an astronaut was, let's say, it was back in, I'm in the class of 2000, so I applied in 1999 for the class. And as a military officer, you have to apply through the military, and that's about 6 months prior to actually going to NASA. So about the beginning of 1999 is when I started putting together my application process, and then I went to NASA after it got forwarded by the Air Force. They have their own screening board. And then typically you have an interview process with NASA, and so it took about a year and a half from the time I applied to the time I actually got accepted as an astronaut. Okay.
Do you recall where you were when you finally found out, when you got the call saying, hey, do you want to come to join the astronaut corps? Tell us that story about where you were and what you were doing.
It's kind of an interesting story because in my class there's 4 of us that are from the Eglin area because I was at Eglin Air Force Base as a test pilot, and there are a couple other people in applying to be test pilots, and my office just happened to be off the main area where we did our flying, and so I would go there periodically, and so I saw a few of the other friends that I had that I knew were applying, and I could tell by their faces they'd gotten a call. Mm-hmm. And so I was interested when I went back to our office to kind of see if I had gotten a call as well. And you can kind of tell based on who's calling you, what it was. And so they told me to call back, and it worked out that the call was a good one, and so it was great to come back and celebrate. So it was an interesting time.
What was your reaction? What was your emotion?
Well, I was elated, obviously. It was a great opportunity, something that I'd dreamt about my whole life to get the opportunity for, and it was a pure joy.
Okay. How would you characterize the value of education in your life? What has it meant to you? What has it enabled you to do? What kind of things?
Education, I think education is an extremely important part of my life, something that is really important to me. And when I go out and talk to other people, I really like to emphasize education because it's allowed me the opportunity to do a lot of different things. I've had the opportunity to fly in high-performance jet aircraft, been a test pilot in high-performance jet aircraft, and then the opportunity to be an astronaut and to really understand how. And I'm really interested in just technology. The world is changing very quickly right now, and it's to me, education, it gives you that opportunity to understand the changes and to adapt to them as they come along.
Okay. What experiences stand out most in your mind about your previous space flight?
The things I remember the most, from my previous space flight, which was STS-133, was one, getting the chance to see the Earth, and I'm really looking forward to it on this flight again. Is just it's amazing, kind of like when you go on a vacation and you come back, things kind of fade over time, and so I'm kind of interested to the colors, the vividness of the planet. That you can really see that the Earth is alive, and also you kind of get an appreciation for how big the Earth is, and at the same time how small we are as compared to the rest of the universe as you're orbiting the planet, and you start thinking about all the stars and other things around there, and also the chance just to see the world without borders. We're used to looking at a globe with borders, but when you're in orbit, everything, you can see it's one Earth, and you can see right now the Earth is, the people of the Earth are kind of getting together and starting to work more and more together as a group.
Everyone on the crew has flown before. You're all veteran space flyers, including 3 crew members who've actually done ISS long-duration space flights. How important and how much of a benefit is having that type of experience going to be to successfully completing this mission?
Well, it always makes things a little easier when you've had a group that's done the tasks that you're going to go do. So a lot of things will be familiar to us. You do obviously do a lot of training on the ground, and the training gets you very well ready for what needs to be done on orbit. But there are a lot of things that you just can't train. What it's like to move around. We call it translation in space. How's it to eat? Just all your kind of basic functions, sleeping. A lot of those things are unknowns until you get up in space. So it makes things a little easier for the group because you kind of know how to adapt. You've done it before, and you know that you can get back there and do it again.
The content of the mission has gone through some changes since you first started training for the mission. Tell us about how that's impacted the training flow and what kinds of adjustments the crew has had to make.
Well, the training flow has changed, and it'll keep adapting right up until launch, and it'll even change once we get up into space. And in the Air Force, we have a saying that basically says flexibility is the key to air power. And I kind of like to apply that in space the same way. Flexibility is just the name of the game, and that's one of the things that we train on the ground is that things are going to change, things are going to be different. We have a flight plan when we go on orbit, and most of the time you only carry the first 3 days of the flight plan with you because the next 4 to 10, 11 days, depending on when the mission is, are going to change once you get on orbit, and they're going to send you the new plan as it comes aboard. So it's change to me is something to be expected, and you always just want to be ready for it. And I think it's an important thing that we train to is to be ready for that change.
How would you characterize the contributions of the thousands of people that work behind the scenes to ensure the success and safety of every mission and every crew?
Well, the thousands of people that are involved in space runs, to me, it's one of the coolest parts about being an astronaut is to realize you're just one piece of the numerous people that make up the mission, and each one of those people, it makes a tremendous difference in the space program. And one of the things I always find interesting is we get to go around and see a lot of the different places, whether it's the vendors that are making the equipment, or the people training us, or the workers that are at the different NASA centers that are actually putting the equipment together or researching what needs to be done. And as you start to ask, well, who worked on this, who worked on that, there's always another 100 people that you didn't know about that's doing some other part of the mission. So to me, it's a very important part of the mission, and what makes working here at NASA a great thing.
If your launch schedule holds, you're scheduled to be on orbit on the ISS right around the time of the 10th anniversary of the arrival of Expedition 1, the crew that started the continuous human presence on ISS. Discuss, if you would, the significance of that milestone that they accomplished, and also space station's importance to the future of space exploration.
Well, Expedition 1, when they went up, it'll be almost 10 years if when we arrive on orbit. It's gonna, it's the beginning of a long process. We've had continuous presence of humans in space since then, and we hope to continue that for, forever if we can do that, because we think, space is going to continue to become more and more important as time goes on. There'll be things that we'll be looking for on new places. Part of it's exploration, finding new places to go, those materials on the moon and everything else. So I kind of look at, our exploration of space kind of like our exploration on many new technologies. You look at the computer, and if I asked you 15, 20 years ago what computers were good for the individual person, most people would have said not a whole lot. But now almost everyone has a computer in their home, or they're carrying mobile computers in their hands. So I kind of look at space in the same way. Right now we're making those steps, and the steps are getting bigger and bigger as we move forward with through history. So I think we'll look back at this time, this construction of this international space station, and a lot of times that gets forgotten, as how much of this program is an international program, and bringing together all these countries in what I would say is the most complex piece of equipment that's ever been assembled is a great thing.
Tell us what the key objectives of this mission are.
Well, the big overriding objective is to leave the space station, since the shuttle is last couple of flights here, is to leave it in the best shape logistically, and also just in every way that we can, so that when the shuttle does complete its mission, that we have the space station in a good condition, so that it's ready to continue on till, right now it's planned till 2020, but the good chance it may even go beyond that. So that's our big overriding goal. But for us, we're bringing up a permanent multi-purpose module, a PMM, which is a big, basically a container that's pressurized and the temperature is maintained. And we're going to attach that to the space station as one of the last habitable volumes on the space station. And then we're also bringing up a platform which is called Express Logistics Carrier 4, which is basically just a big pallet in the back that we're going to grab with the robotic arm and attach that. And it's going to carry some spare parts and will be used in the future. So those are kind of our big payloads. And then we're doing some spacewalks, which are kind of finishing up the last, kind of get the last finishing touches on the construction of the space station to make sure it's in a good configuration before Shuttle finishes up.
Okay. And as the pilot, talk about, if you would, just some of your key responsibilities in that capacity.
Well, the pilot, along with the commander, we kind of split up these roles. Works fairly heavily on basically operating and maintaining the space shuttle. So one of my big jobs as the pilot is just working kind of the systems of the space shuttle and keeping everything kind of running smoothly. Other jobs that I do is I also assist with flying the vehicle. I'll do the undock and fly around on this mission. I'm also working on the robotic arm on the space shuttle. And so we'll be doing some robotics both to inspect the shuttle. We do an inspection pre-docking and post-docking, and we'll also do some robotic work where we're handing off that ELC-4, that pallet, from the payload bay up to the space station arm.
Okay. And to the best of your knowledge, the PMM, how has it been configured, or what's been different about it to make it give it the ability to be permanent?
It's a great question. Basically a PMM, which is the permanent multi-purpose module, which is basically taking what we used to call an MPLM. On my last mission, STS-133, it was called an MPLM, multi-purpose logistics module, and basically it's been converted. What they've added is added on some basically micrometeorite protection, so it'll help it if it gets struck in space. So they've taken off some things that don't need to be used anymore, so reduce the weight so that we can carry more things up to orbit. And they've also just kind of looked at the interior and added some small modifications that make it work better for a permanent module.
Okay. You're also scheduled to deliver Robonaut R2 to the station. Tell us what you know about R2 and what its purpose is going to be on station.
Well, Robonaut's kind of going along that idea of technology that we've been kind of talking about in today's interview. Is robotics is kind of coming into that age where it's getting more. Basically, we're trying to look for that synergy between humans and machines. We have a lot of unmanned aerial vehicles, UAVs, that are out flying around, and they're working with humans. And robots, we use them in all kinds of different factories. But this robot, Robonaut 2, looks more something like you'd see in a science fiction movie. And so we're looking for those areas where we can kind of build on the strengths of the machine and also the strengths of the humans, and look for that synergy where we can get the most out of to achieve the mission using robots.
Okay. The day after you make it to orbit, you're scheduled to do an inspection of the shuttle's exterior tiles. Talk us through what's going to happen during that process and what your involvement will be for that.
Well, I'm one of 3 crew members that's going to be doing the tasks. It'll also be Al Drew and Steve Lindsay, and the 3 of us are basically working together to accomplish the inspection. Of course, we have a huge team on the ground that's really helping us analyze all the video and the data that we get from inspecting the wings. But the process is basically we have the robotic arm from the shuttle that we reach back and grab a boom, a sensor system that we have on the other side of the sill of the space shuttle. We'll pull that out, and with that extra boom, it gives us more length, and we can actually look at the front leading edge. We call it RCC, the leading edges of the wings of the shuttle, and we check both sides of that. And we're also going to look at the nose cap and some other big tile areas and other big areas that we can take a look at. And all that data is going to be processed in the ground. And again, hundreds and hundreds of people on the ground are going to analyze that data and see if we basically took any damage in this pre-docking inspection, if we had any damage from ascent, is primarily what they're looking for.
Okay. Walk us through, if you would, too, also the rendezvous and docking phases of the flight. What are you going to be doing for that?
Well, as a pilot, you do you're basically the whole crew is going to be working on rendezvous and docking. But as a pilot, I'm primarily assisting the commander and kind of getting the profile right and doing the orbital burns. And right after we get onto orbit, we're doing orbital burns that are actually setting us up for the rendezvous. But primarily on the basically our 3rd day up in orbit, after we do the inspection flight, we call it flight day 3, is where we usually do the rendezvous and docking, and it's basically a bunch of orbital burns, small burns that correct our orbit, and as we get closer we make smaller and smaller burns, and eventually we take over visually, and then from the visual perspective we fly around the space station. As the space station's flying around, we kind of pull up in front of it as we're going around in orbit, and then we end up visually docking with the space station.
Okay. On that same day that you docked, I think you touched on this before, that you're going to also, post-docking, get to taking that ELC-4 out of the payload bay. Can you talk us through that process and up to telling us specifically where ELC-4 will be temporarily stowed, I guess?
ELC-4, again, that's a pallet that's in the back that's right now is carrying a radiator, and it's also got some other devices that can carry other boxes that we can use in the future. It's basically kind of a good storage location, but primarily what we're carrying on it that it has is a spare radiator that we can use to cool some of the systems on the space station. Anyway, once we dock, right away, even before we open the hatches, the space station robotic arm is actually going to reach in, grab the pallet, and basically pull it out, put it in a position. Then we're going to use the shuttle arm. We'll actually have set it up to get some views so that the space station arm can actually, it'll make it easier for them to grab the pallet. They're going to move it out to a position, then we're going to take the robotic arm of the shuttle, grab the pallet, and then now the space station arm is actually going to reposition itself, so it's actually going to have to, we call it a walk-off. It'll have to change the place where it attaches on the other end move down and get itself in a position. Then it will grab the ELC-4 again from us. We'll move out of the way, and then they will actually end up putting it on the starboard nadir side of the space station.
Okay.
On the truss.
And is the process of getting the PMM out about as involved? Is it?
It is. It's fairly involved. You know, we're moving it. It won't involve the shuttle arm, but it's again going to be a process of getting it out and getting in situation, a position that we can put it in to berth it.
Okay. Now you aren't directly involved with the EVAs, but if you could just kind of give us a synopsis of what Al Drew and Tim Coper are going to do on just conglomerate them both, basically. If you just kind of some of the tasks that they're going to do.
Yeah, their big tasks that they're going to do on the spacewalks is again get it in the good configuration. There's some lights that need to be repaired or changed out. They have covers that needs to be secured. One of the other tasks they're going to do is we have these. Basically, it's like a small train system on the truss that we can move back and forth that can carry the robotic arm. And on the end of that track, we took off basically the stoppers to keep it, and they're going to install a stopper on one of those. So a lot of different tasks, and I'm sure those tasks will probably change once we get to orbit because there's, priorities change, and so they'll be adding on to that. So they've got a lot of different varied tasks to get us in that good final position.
Okay. You will, however, be involved with activating the PMM. But what does that involve?
We'll have just berthed the day prior the PMM underneath, and so now we're going to get into the PMM. So activation involves basically we got to open two hatches, and because there's a hatch on the station side and a hatch on the PMM side, and there's obviously an area in the middle that we call a vestibule. And so we're going to have to equalize the pressure between these two, also get the temperatures right, check the seals, make sure that those are well. And once we open the station side hatch, we're going to have to look in, and there's covers on that to protect them from the cold, or basically from the environment of space. We'll take those covers off, and then we're going to have to set up the long-term linkage that's going to be between this permanent module, so it has to talk to the computers on space station, so we'll have to hook those lines up. There'll be commands that have to be set. And again, Scott and I will be working on this together to put these things together, but again, there's a huge team on the ground that's analyzing a lot of this data that's being sent down to make sure that we're at the right configuration that we want to be in before we open all the hatches.
How long of a process is that, and what is it? What kind of things could possibly throw a wrench in?
Well, it's there are all kinds of things that can always there's always the unknown is always the challenge, but we have contingencies for all those things, but a lot of times there's things that you haven't even thought of or something completely different, but usually from those other contingencies that you thought of, it helps you get your plan started, and we usually figure out a good solution to come to. But it's going to take anywhere from 4 to 6 hours to get it all configured and get everything the way we'd like it set up for opening it up and getting inside.
After your work on station is complete, you'll undock and make the preparation to return to Earth. It might be one of the last opportunities for anybody to see space station from that vantage point from inside of a shuttle backing away. As you sit here today trying to imagine that, how profound is that, and what's going through your head about that?
Well, it's always neat. I've only done it one other time for myself on my last mission to actually fly around and look at stations. So just getting the opportunity to do it at all is truly amazing, and the fact that it may be one of the last times that a shuttle gets to do it is it's honored to get the opportunity to do it, and I will be appreciating every second, watching it and really just trying to put it in my memory. Just like when you're on a vacation, you're watching something that's really neat, or going to some other type of event. I will try to record all that in my memory bank so that I can play it back for years to come.
This mission is also scheduled to be one of the last shuttle missions. What does it mean to you to have had a part in the shuttle program? It's something that many consider to be an American institution. Oh,
it's great. Great to have the opportunity to participate in the space program. From all the people I know that have participated in the space program, and there are many, it's a great opportunity to be part of history, to see all these things happening and seeing as we advance in space. It hasn't been that many years ago that we walked on the moon, and here we are, have a fully completed space station almost. And, we're at that point where now we've had continuous presence in space for about 10 years. So there's many exciting things happen in space, and I'm looking forward to exploration that we know is going to happen in the future, going back to the moon, onto Mars, and onto a lot of other different bodies out in the galaxy and on into the universe.
Okay. Can you give us an idea, if you can from memory, right off the top of your head, what maybe you remember some of Discovery's magical moments or greatest hits? If you had to compile a list of some of the missions and events that Discovery's been involved with, what top 2 or so would have to be on that list?
Well, Discovery's had a lot of kind of great firsts. It's been the workhorse of the fleet. It's really done a lot of great things. It's been on 2 return to flights after Challenger, and after Columbia it was a return to flights. It's the only orbiter that's actually flown 4 missions in the same year. It put Hubble in space for the, and we just had a Hubble repair mission that just happened. So Discovery has really had the opportunity to see the full spectrum. They also went up to Mir for the first time, got up really close to it on the first rendezvous. They didn't dock with it, but then they also did the last docking with Mir. So it's had quite a long history, and it's an honor to be on one of the last flights of Discovery.
Okay. How would you characterize how the space shuttle, the vehicle, what it's meant to the advancement of human space exploration?
Well, the space shuttle is really an amazing vehicle if you think about it. They took technology from the 60s, like the X-15 and a lot of other things that test pilots worked at, to look at a vehicle that could re-enter and land on a runway. And to actually, I got on it and started flying it for the first time in 2008. And I've been at NASA for years before that and studied it. And it is truly an amazing machine when you really think about the technology. And it's still amazing today, even 30 years later, that we can build a vehicle that we can put in orbit and actually land on a spot on the Earth of our choosing. And so I think that's a great thing. And I think in the future there will be other winged vehicles that we'll see that we'll use to get from one place to another on the Earth.